So welcome to Web Applications for Everybody. I'd like to take this first lecture to talk a little bit about the core technologies and the people that built some of these core technologies. Of course, every one of these requires a group of people, but I have some cool interviews that I'd like you to take a look at. Not so much because I want you to memorize what they say, but I also want you to understand the kind of people that made these things and how technology is made by people. We're people, and people made technology. Nothing's perfect. Everything is a set of compromises and a set of choices, and so there's no magic to all this. And so if you say, well, this is kind of funky or flawed, it's funky or flawed often because it wants to be like that, or it's naturally someone made a choice. And so we'll talk about the web server, we're going to talk about the PHP programming language, SQL, the language you talk to databases, how we talk inside the browser using JavaScript and jQuery, which is like a library that makes Java client-side coding so much easier, and then how we send data back and forth between the browser and the server using a protocol called JSON. So the foundation of everything we're going to do is the Apache Web Server. It's an open source project. It was part of the 1992, 93, 94 project at NCSA, the National Center for Supercomputing Applications. That was part of the Mosaic. And the Mosaic was a browser, a client, and the Apache Web Server was the HTTPD, which stands for Hypertext Transfer Protocol Daemon. Daemon was the thing that was always there so the client could talk to it. When the Mosaic project kind of went down at NCSA, it was open source, and a bunch of people picked it up. And Brian Behlendorf was one of those people. Apache stands for, depending on your interpretation, Apache, like very patchy web server, because they kept patching this thing. And that created the Apache Open Source Foundation as the first product. It's open source. It's written in this programming language called C, which is a very low-level and powerful programming language that really underpins lots of the technologies that we use. And so this is sort of a slide where I talk a little bit about the history of all these programming languages. And so C is an interesting programming language because in 1972, it's the programming language that was used to write Unix, was used to write Linux, was used to write Python. So if you look at Python itself, Python is written in C. And so prior to C, in the beginning, we tended to do lots of calculations. We saw computers as really fast calculators, and so a lot of the things we did was either write very simple machine language programs or Fortran programs that really were trying to use it as a fast calculator. And so sometime in the 15, 20 years between the 1950s and the 1970s, we realized that computers were going to be used for things like email and social networking and sending text. And there was a whole bunch of fancy text languages that were built, but none of them really were a combination of text-savvy languages and super fast languages. So the first language that I recall that was both really good with text and good with numbers and really fast and suitable for writing systems kinds of programs was this language called C. And a lot of us fell in love with it. It was a very succinct programming language. It uses curly braces for if statements and for statements. It uses this fork syntax with the two semicolons in the middle. And so if you've seen Java or JavaScript or C++ or Objective-C or C#, you've seen this language, because all of these languages at the top here, the kind of system-y programming languages, they're very much cues. JavaScript is kind of on the gray area between fun languages and system programming languages. But they all took their cues from this C language, which was used to write, like I said, Linux and Unix, and even Python is written in C. So Python was written in C. And in addition to the sort of system-y languages, there's a whole series of easy-to-use languages. And Perl was this language that stands for something report language, and it was about sort of handling simple data stuff. And Perl was really an inspiration for Python, but Python was written in C, and so Python took a lot of inspiration from C. And I hope by now that you know the Python language. And the PHP language, which is another of the languages we're going to learn in this series of classes, it's also written in PHP. It took a lot of inspiration from C. PHP is written in C and takes a lot of inspiration from it, but it also takes a lot of inspiration from Perl, and to a lesser degree probably inspiration from Python. And this bottom set of languages, these are really simpler programming languages that have simpler primitives that are easier to use. And JavaScript kind of lives in the middle. JavaScript is increasingly both a system programming language and kind of a lightweight fun language, and we'll use it in some ways for both things. So JavaScript is a very interesting language. I prefer not to teach JavaScript as the first language because it's so sort of beautiful, elegant, and powerful. I mean, it's easy to find a little bit of code and stick it in your web page and have it work, but to truly understand JavaScript, it's probably better for it to be your third or fourth language that you learn. And if you've learned Python and PHP and SQL, HTML, and CSS, and then you finally learn JavaScript, to me, that's the right order. And that's the order that we're going to do in this class. So, but I still want to introduce you then to some of the folks who've built these basic technologies. So the PHP language is a programming language that is a templating language that's merged into HTML pages. And so it's like you've got HTML and then code and HTML and code and HTML and code. And so it's very easy to add little tiny bits of dynamic calculations and dynamic code to part of a web page. So some of the web page comes from code that runs and has print statements in it, and then some of the web page just comes from the HTML. So PHP was created by a fellow named Rasmus Leerdorf. Now thousands of people maintain it as a large open source project. Rasmus was not a trained computer scientist. I encourage you to watch his video. He'll honestly tell you that he's more interested in practical, easy to use stuff than he is about building the world's greatest programming language. Now, PHP is from the 80s, and so it's almost 20 some years old, and so it's gotten more elegant as time has passed. So PHP 5 and PHP 7 are much more elegant than PHP 1 and PHP 2. But the idea is to get you as the programmer building a web application productive as soon as possible. He was having trouble in the mid 1990s because he was writing all of his web pages in C, and C is very, very, very hard. So take a look at it. And Rasmus is a fun guy, and PHP is very much a reflection of his early approach to building it. SQL, I hope by now perhaps you've seen a little bit of SQL. SQL is a glorious and beautiful language. SQL basically takes a very complex problem, and that's how to optimally store data in memory of the computer and on the disk of the computer and get things next to each other that are likely to be pulled up at the same time. Joins and inserts and selects and updates and deletes. And databases themselves are like super complex. I mean, you could have 20 careers with PhDs in all 20 of them, and you still wouldn't know enough to know all the stuff that database applications are capable of doing. But we have this thing called SQL where all that complexity is beautifully abstracted for us, and we just say, I would like to do this, and you magically figure it out. So that magic figured out is full of PhDs in computer science, but we don't have to worry about that. And SQL is such a beautiful language. The birth story of SQL is a little different than the other languages. In the 60s, all the database vendors, IBM and Oracle and Sybase and companies that don't even exist, were fighting over the marketplace. And they all had a different view of how databases should be built. And so they did. And each one would have their PhDs in computer science. They would build different databases. And they would build different languages to talk to those databases. And then the US government, in the form of the National Institute of Standards and Technology, NIST, said, look, we're tired of arguing with you about which is the best database. And what we need is a standard language to talk to any database. You can implement them any way you want. Go ahead. And so they said, hey, you industry people, you get together and you develop a standard. And SQL was that standard. And Elizabeth Fong, I did an interview with her, went to visit her at NIST, and she talks about how this happened. And it was kind of a magical thing because all these vendors got together and produced something beautiful. And it wasn't abstraction in that it really wasn't a direct implementation. The language didn't directly implement any of the vendors' databases, but it was a way to talk to any of them in a very beautiful abstraction. So it turns out to be a very, very beautiful language, and I think you'll agree once we get talking to them. So after we're done in the server, we're going to start playing in the browser, in the client. And so JavaScript is like this C-like programming language, and that has curly braces, et cetera, et cetera. But its early design was to be done inside of a web browser, web page. And so it actually has these predefined constants like document and window that allow it to mess with your browser. So you're sort of watching your browser page, and JavaScript is sneaking around and fiddling with the page and doing things, and you're seeing those changes through what's called the document object model or the window, where that's how you can be in a page and like, boop, a new thing pops up. Boop, boop, little red bot. That's all done with JavaScript. And so JavaScript is really cool. It was in 1995. Brendan Eich was the inventor of this. It was at the Mozilla Foundation, part of the Netscape project. And I encourage you to take a look at Brendan's video. Brendan is very different than Rasmus in that Brendan is even smarter than a computer scientist. Brendan is a physicist, which we good computer scientists look up to physicists because physicists are so smart, know a lot of math. Brendan really saw JavaScript as his chance, in a very hurry, without really telling anybody, building what he considered truly the most beautiful programming language that humanity had ever seen. That's how high of a goal he had for it. And he's just smart enough that he'd seen so many languages, he had things he liked about them, and he sort of took that C-like language from Java, the C-like syntax from Java, and built a very beautiful language. And when I get to telling you about like how object-oriented PHP compares with object-oriented JavaScript, I'll totally geek out about it because I'm like, look how elegant this is. And you'll be like, just show me the syntax. So what I'm saying is JavaScript is a beautiful language, and that's why JavaScript keeps increasing in popularity. You may be working at an organization that uses JavaScript in the server in addition to in the browser using a framework called Node.js or other JavaScript frameworks. And so take a look at the JavaScript interview. It's really, I think, quite cool. And again, sense the personality of these people. Now, JavaScript is this beautiful programming language, and it talks to the browsers through this thing called the DOM, the Document Object Model. And they standardized JavaScript very quickly. So JavaScript is all the same, but they didn't standardize the document object model, the things that JavaScript does to change what's going on in the browser, okay? And so the problem was if you had Internet Explorer 6 or Internet Explorer 8 or Chrome or Firefox, they all were different. Not JavaScript, but how JavaScript did things in the browser. And so jQuery was a portability layer that was built by John Resig. And it was a very elegant and portable way to do things in the document object model. And so John is like 10 years after all these other folks in that he is trying to make it easier for us to do. So a lot of people these days just assume jQuery is JavaScript because it's a better way to talk to the document object model, and it's a really great way to do stuff, and it keeps our code in the browser much shorter. And so I encourage you to take a look at John Resig. And so the last thing we're going to talk about is what's called JSON, or JavaScript Object Notation. And that is basically the format of data that once you have really smart browser code and really smart server code, and the code, instead of the page, but the code behind the page wants to talk to the server on your behalf and start sending things without even you doing anything. You'll just be like, and it'll send something. Like, go check to see if there's any new messages. Go check to see if there's any new messages. Well, the new messages come back in a format called JSON. In this video that I have, Douglas Crockford, who doesn't credit himself as the inventor of JSON, he is the discoverer of JSON. And that's because it was actually part of JavaScript. He just took part of the JavaScript language and created a protocol that then captured that, and then we use that for a lot of different things. And so I encourage you to take a look at these videos when you have some time. They're not essential, right? You're not going to learn JSON from watching a Douglas Crockford video, or you're not going to learn from Liz Fong's not going to be able to teach you SQL. But I think it helps you to understand that all these things are the creation of people, and people working together to kind of come up with something, and there's all kind of compromises, and it's all very interesting stuff. And you may ultimately end up writing with Node or Ruby on Rails, or who knows what you're going to write your web applications. But at the end of the day, everything is something that we people have created, and then we people use from each other. So now we're going to talk about how web pages get constructed. Now you might say, why are we looking at all this detail? Partly because what I want you to really understand is how web applications work. Because web applications, and frankly many mobile applications, have multiple layers of components, multiple parts that work together. In a web browser, you got the browser, and then you got server, and then you got a database server. And so what I want you to understand is I want you to be able to, as you write code, know what part of this multi-system that you're working with. And so the browser is the thing that runs on your hard drive. It might run on your phone or something. And the technologies that we're going to learn are like HTML and CSS. Later we'll learn about the document object model, which is a way of, HTML is what formats this, CSS kind of picks the fonts and things. And the document object model is the way that JavaScript goes in and plays with stuff, changes words. We'll learn all that, how that happens. And jQuery makes that even easier. And so we have a lot of technologies in the browser that we're going to learn, and then we're going to have a lot of technologies in the server that we're going to learn. We're going to learn about PHP so that we can write code in the server. We're going to write SQL so we can find stuff hidden throughout in our databases and bring that all out and send it back. And then we're going to learn about the request response cycle, and that is where the browser is talking to the server and we're writing code in the server to respond, and what goes back and forth, and that's HTTP, Hypertext Transport Protocol. Also JSON. We have JavaScript talking and getting data back and forth that uses JSON. And so in this first, I have to start somewhere, right? And so where I want to start is I want to start to give you a sense between what goes on in the browser and what goes on in the server. We'll talk a little bit about the Hypertext Transport Protocol, but mostly I'm trying to give you a way to realize that there are different pieces of code and technologies that are being used in these applications. So HTTP is the dominant application layer protocol. It was invented in 1989, 1990 by Tim Berners-Lee and Robert Cailliau when they invented the web. And there's other protocols that predate HTTP, like FTP for file transfer, Telnet, SMTP for simple mail transfer. These are all well developed. But Tim Berners-Lee and Robert Cailliau, they wanted a easy protocol, mostly because they weren't protocol developers. They just wanted to build an application that could show pages and let people edit those pages. So they kind of built the simplest possible protocol. Some of these protocols go back and forth and back and forth. In HTTP, it makes a connection, it asks for a document, and it gets a document back. It's really quite simple. And I'm not sure it was engineered to be simple, but what happened was we were able to layer on top of this simple things like web services and other things that are kind of just a slight variation on it. And so most of the new protocols that we use are simply protocols that sort of take a different convention on top of HTTP. So it's beautiful in its elegance, and it's the only one that we can hack because it's so simple that we can hack it. I used to be able to hack the mail protocol, but then security got in the way and made it difficult to use. Another of the core contributions of HTTP, again by Tim and Robert in the early 1990s, is that the notion of a uniform resource locator. Now you'll find this on, you'll pick up a brochure, it'll be HTTP : blah, 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 blah. And you're like, oh, okay, I know what that is. And I type that into my browser and I go get a document or a set of documents. But there's actually some science that goes into these uniform resource locators. And before the web, you had to know what host to go to, what protocol, what set of commands to send to that host, and then what kind of things on that host that you might want to retrieve. The URL just comes up with a convention and then concatenates these things together. So HTTP:// is the protocol. There are more than just that one. The server that you talk to, and there's like out in the cloud, there's like server. Which of these servers has the document? What protocol is what we do to talk to it? And then within the server, there's files. And so this document within the server tells us what we're going to look at. Now, it's more complex than that. You can put parameters on the end of this. You can put what are called anchors on the end of it. So there's all kinds of things, x = 2. But that's the basic idea of a URL, is how to get it, where to go get it, and what to get, all concatenated into one long string. And so the idea is if we have one of these URLs and we type it in the browser, we get it. The other way that we can do this is not just typing the URL in the browser, but embedded in the HTML are what are called anchor tags, which are clickable links that have an href. In the next HTTP lecture, the href that says, oh, when someone clicks on this link, throw this page away and go to a different page. And so it's the hypertext aspect of it. So you click on a link and then you go to the next link. And so the link turns into a GET request, which retrieves a page, which gives us back new HTML, which then is shown in our browser. And so the first thing we're going to do is type a URL. So if you type data.pr4e.org/page1.htm and then you hit enter, you have told it to go get a GET request. And if I take a look at the source code here, view page source, you might have to put like a developer mode on or something to see view page source. But we can see the page source here. You see this markup. This is HTML. We'll talk about this in some detail. And this is an anchor tag that says when this second page is clicked on, go and get this URL. So we're on page1.htm and this is page2.htm. And so if I click on this, it'll just be like instantaneous. But we've been to another page and there's a link back to the first page, back to the second page, back to the first page. Okay? And so that's basically hypertext navigation, but our browsers are doing things and seeing these little clicks and then doing something, getting a different page. Now, of course, it's far more complex than that, and we'll see that in just a moment. But I want to go and take a very close look at exactly the steps that happen with this simple hypertext navigation. So at some point, we typed our URL into the browser. We hit the enter key, and that caused a GET request to happen, and now we see this page. And now we have an anchor tag in there that's a hypertext reference. And in the early days, they were all colored blue, and they all were underlined because people needed permission to click on things. We're so used to looking at pages that you couldn't click. Now everyone thinks hypertext is right, and you'll just click on everything. See what can I click on here? Well, in the old days, we used blue text and underlines to say click here. So when you click on this, your browser is a piece of code that's running on your computer. So this big white box is your computer, whether it's your phone or whatever. Browser is a piece of software like Chrome, Firefox, Internet Explorer, I guess they call it Edge now, Safari, Opera, lots of browsers. Those are software applications that are your client that views the web. They're a browser. So the browser is an application. It's the thing that is showing you this page. And when you click on it, the browser on your computer says, oh, somebody clicked on a link. And it goes and looks to figure out what link you want. And then when it knows what link you asked for, it then makes a connection based on parsing that link. It makes a connection to the right web server on a port called port 80, which is the normal port for web servers to live on. And then it sends a request. It sends a little line of text that looks just like this, sends this whole line, says that is the document I want. Then somehow in this web server, this is the internet, right? This is the internet, and this is somehow on this web server, it either generates the response or reads it off of a disk or something, and out comes the response, and it comes back to us. And that response itself is in the format HTML, hypertext markup language, just like I showed you in the view source. These are tags, end tag, 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 and then there is a hypertext reference here that turns this second page into, turns this first page into a hypertext link. And this was purple because I clearly clicked on it before I took the screenshot. So when this HTML comes back, your browser parses it and then renders it. There's the document object model that's kind of in the middle here, that it parses it, puts a document object model, and it comes to your page. But that's the basic idea. You click request, page is done, response, parsed, shown, and you get the page. Click, request response, click, request response. Now, it's going to be way more complex by the time we're done. There'll be like many request response cycles, okay? But that's the basic request response cycle. Now, this is all governed by internet standards. And the internet standards come from a very open source and a very open culture. They were developed by a group called the Internet Engineering Task Force that predates what we think of as the modern internet, which is mid-'80s. The IETFs came from even the 70s, an earlier network called the ARPANET, and they came up with the idea of the IETF, Internet Engineering Task Force, and these standards. And these standards are open, they're free, they're unencumbered, meaning that anyone can read them and implement things that comply with these standards, and then as such build yourself a web browser or build yourself a web server if such a thing doesn't exist. Of course, these days all these things exist and we just download them, but the sort of thing that governs the protocols that we all use so that our code interoperates are these IETFs. There's other sources of standards like the World Wide Web Consortium for things like HTML and CSS, but the protocol stuff is very much through IETF. Now the fun thing about this is these are the name of these things are called RFCs, which stands for Request for Comments. And that's kind of a nerdy engineering acknowledgement that no standard is ever perfect. And even when they're done and they are 10 or 15 years old, or like 1981 to 2017, that's like 30 some years old now, they still might need to be improved. So that even though it's 30 years old plus, it's still waiting for comments. If you have a comment, if you find something wrong, or you have a better way to build it, then engineers want to hear about that. So that's kind of a fun, ironic naming conventions for these internet standards, RFCs. And so if you were to pick up, there's many standards that govern HTTP, the Hypertext Transfer Protocol. You go read them and you could page down, page, and you will realize quickly that you don't want to write a browser. You'd much rather use a browser, but eventually you'll get down to a page way down that basically says how to make a request. And if you keep looking, it tells you that you're supposed to put the method followed by the URI, a protocol version, and then end with a character trend line feed, right? That's what it's saying right here. The method token, which is going to be get in our case, followed by the URI, URL, ending with a character return line feed, et cetera, et cetera, et cetera. And so if you read long enough, you could eventually see how we're supposed to do that. And so based on how we're supposed to do that, up next, I'm going to show you how to manually hack an HTTP request. So now what we're going to do is we're going to try to dig even a little bit deeper in how these HTTP requests work, and we're going to make one up by hand. I'll show you how to talk to one by hand. So if we look at the RFC, we see that we make a connection to the server. In this case, we're going to go to data.pr4e.org. And I'm using the original old protocol from 1990. And increasingly, servers are refusing to serve documents using the old protocol. They want at least HTTP 1.1. But so not all servers do this, but this data.pr4e.org, I've got it on a special ancient server. So it always talks HTTP 1.0. So I can do this demonstration. HTTP 1.1 is similar. It's just a little more sophisticated, but it's harder to type it by hand, okay? And so that's why I use an old server that does HTTP 1.0. The HTTP 1.1 still has a get thing and a URL, and it just has more stuff afterwards that you got to put in. So, but let's go back to the basics, back to the way it was in 1990, 1991. And that is you talk to your server, you send a GET request, and hit enter, and then away you go, okay? So here's kind of what I'm going to show you. I'm going to use a command on my Macintosh called Telnet. Telnet predates the internet. It's one of the early protocols, FTP, File Transfer Protocol, SMTP, Simple Mail Transfer Protocol. Telnet was the way we logged into servers, but I'm going to connect to the server, but instead of connecting to the normal login port, I'm going to connect to port 80. Port 80 is where we expect a web server to be listening. And so if there's a web server, then it will connect, and then it will stop, and then I will type this command. Hopefully I'll type it fast enough for the server to not run out of patience with me. Then I'll hit the enter, and this is exactly what the server is going to do. So I'm typing this, and the server is going to respond this. This is the request, and this is the response. And you can do this too, but realize that fewer and fewer servers talk the classic HTTP 1.0 protocol. It's so sad. But I keep this. This is my antique server that I can talk the old protocol, okay? So I'm going to start this up. Oh, by the way, if you're on Windows, it doesn't come with Telnet, but the bash shell probably might come with Telnet. I don't know about that, but you can Google how to make Telnet work on Windows, and so then you can do this on Windows also. You can make Telnet hostname space port name, and it should work. You should be able to eventually do this on Windows. You just can't do it out of the box. Linux, of course, this worked perfectly on Linux and Macintosh right out of the box. And so now I want to show this to you in Telnet. Now again, you have to do something a little weird on Windows, but on the Macintosh it's easy. So I'm going to type the command telnet. This is just a local command, data.pr4e.org. So that's the server I'm going to talk to in port 80. So there's all these web servers or mail servers or whatever servers, and there are ports, which are like phone extensions that tell you what application to talk to, and I'm trying to talk to a web server. And you'll see it's going to use that information to find the IP address, the actual address of the web server, which is 192.241.136.170. Now, it is waiting for me to type an HTTP command. And I got to type get, which is the verb that's give me a document, and then I have to type the URI or URL, ://data.pr4e.org, page1.htm. So this is what your browser is sending, HTTP/1.0. Now I have to hit enter, and then I have to enter again. So now the server responded. And so if you look, this is what I typed. I typed that, and I typed this blank line. I typed that, and then the server came back. This is the entire server response, and then the server closed the connection. That's Telnet telling me that the connection got closed. So this is a super simple protocol. I type 2 lines, and I get all this data back from the server. And this data can be broken into 2 parts. The data can be broken into a header part and a body part. And so there's a blank line here, and that's exactly what the protocol says. There's a blank line between the header of the response and the body. That the browser knows things like how big this file is, that's how big it's going to be. It knows that it's not supposed to be cached. It knows that it was last modified on this date, and what kind of a server. We're talking to an Apache server. Remember, I was talking about Apache in a previous thing. And this running on a Linux operating system called Ubuntu. And one of the more important things in here is this content type, which tells basically the kind of information. So right now this is an HTML page, and so it says the thing I'm about to give you after this blank line is HTML. But this could be an image or something else, and then we wouldn't be able to look at this very well. It would look like, but it would be really the image. And so if you're bringing pictures down or PDFs down or whatever, you get the actual picture of the PDF here. But because this is HTML, we get HTML, which has tags in it, and it's got its own little anchor tag, an href, and some new clickable text, etc., etc., etc. And so this is sort of what the browser is doing on your behalf when you click on a link. Okay, so that's what happens. Those of you who've had classes from me before, you know that I am obsessed with the command line. And you may or may not have heard me told this story. This is a movie scene that was written by one of my former students. His name's also Chuck. And it was initially in The Matrix Reloaded, where Trinity is breaking into the power grid to shut everything down. And this is actually command line hacking. The scene was originally written for some kind of a Minority Report-like UI, and he said, that's not how people hack. People hack in the command line, just like I just did. And so part of all cool security hacking movies now is doing something in the command line, and that just reinforces how much I love the command line and how much I want you to be able to know how the command line works, just because it's super cool. And you can also take a look at the URL and watch that. Another part of this class, ultimately, is to get to know our browsers. And so I just showed you how to hack it, but you don't really need to do that. That's the hardcore way. Even though sometimes I do that to figure out what's really wrong, because I have to type the HTTP 1.1 protocol, which is harder than the HTTP 1.0 protocol that I just showed you. And so our browsers have this developer mode. Safari has preferences. Sometimes you have to turn these things on. So I want you to go turn them on, and I want you to be able to look at this stuff, because this is where you, as a normal web developer, are going to diagnose problems with your application. Because like, did it screw up in the client? Did it screw up in the server? Was there bad data going back and forth? And so you're going to get used to this, believe me, by the time you're all done. And concept of developer mode, even if you're not even writing the application, it's fun to go figure out when stuff breaks, what's going wrong in someone else's application. And so let's take a look at this. So let me bring up my browser here. Take a look at a web page, www.dr-chuck.com. When I type that URL, that goes and does a GET request. But this is a much more complex page because it has pictures and stuff. And they don't come down as to all with one request. And so I can do View Developer Console, and I can see things. And so I'm going to go and take a look at my Network tab. And I'm going to do this again. And so I'm going to highlight it and type Enter, which causes that initial GET request to happen again. And then you can see all of the network requests that happen. Okay, and so what happened is to generate this page, it did 71 request response cycles. And if I scroll all the way back up to the top here, this was the first one. The first one was a GET request. Okay, this was a GET request. It was a GET request to this URL and 200 OK. Oh, I forgot to show you. Let me see if I still got it. I forgot to show you that the first line of this header response is an indication if it's good or not. 404, for example, says I didn't find it. So this was it did find it. If I had made a typo mistake here, I could have got a 404. Well, let me do this. I'll make it go a 404. I'm going to say get http://data.pr4e.org/page4.htm, which I know doesn't exist, http://1.0. So this is a URL that doesn't exist. This is what happens when your browser sends a request and it doesn't get a page back. See, 404 not found. It's first line of the header. Again, I typed this stuff, first line of header, 404 not found, then the blank line. Now it says something about, hey, I couldn't find it, but also sends this 404 not found. Like I said, you don't have to do this by hand. You do it here. And it says, oh, you got a 200. And then it got all, remember the headers? The headers are sitting right here, response headers. If I go to data.pr4e.org/page1.htm, there we go. So this is that page, and look, we asked for this URL. This is what we asked for. We did a GET. We got a 200 OK. The address was, this was the address. Away we go. And here's the response headers. We saw those response headers. They're pretty much the same as these response headers. And the HTTP 1.1, we used HTTP 1.1 in this one, and we actually sent a bunch of other stuff. This stuff here that says, you know, what my preferred language is, what kind of browser I'm using, et cetera, et cetera, et cetera. And so that's some of the data. This request header stuff, it actually goes right here. Remember when I typed that Enter key? you know, there's a bunch of stuff that goes here, and then you type the enter key, and it's all these request headers that are communicating to the browser communicating to the server something about what your browser is doing. You'll get better at this. So there's the request headers. Then there is the response, which is the body part, right? That's it's showing you the headers over here, and then the body over here, and then the preview if it has a preview, but we're not going to worry about that. So now let's go back to this one. So it got some page, www.drchuck.com. It was a GET request, 200 OK. This is the IP address of that server. And we can take a look at the response, and it's a bunch of HTML, blah, 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 some CSS, blah, 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 blah. And that's the first page. Now, the problem is in this page, you know, we haven't done HTML yet, but in this page somewhere, there is a picture that says load this image. And so it reads this as your browser is reading and parsing this. It's, oh, I got to go get a picture. So it goes and does another request response cycle. So here's the request for drchuck.com, Ian Dolphin small JPEG, which is that little picture in the upper left-hand corner. And it got a 200 OK because it already retrieved it once. And the response, it was an image JPEG. Remember, the other one was an image text HTML. And so that's the response headers. I don't know if I can see a preview. Yes, you can see a preview. It would look yucky, so we don't see the actual text of the actual response. So there's the second request. Then it went to this rate my professor picture, then some other thing, and on and on and on, away it goes. And it just read that, and it just had to get all kinds of other things, JavaScript and widgets. Now we will eventually write applications that do lots of these things. And like I said, eventually, it did 78 requests to get this page constructed. So there's a lot of things that you can do, and some of the early assignments will be asking you to do things with this developer console, again, so that you can really get to understand the request response cycle. So we have so much more to learn. Technologies in the browser, HTML, CSS, the DOM, and JavaScript, jQuery. In the web server, we got our web server, PHP, MySQL, all these things. We got so many things. And this is the picture that you're going to get tired of, because this is my favorite picture in the whole world, because I can tell you in this picture about the browser that has a document object model, and I'll draw pictures that look like this. And don't worry. So this is where HTTP happens, so there's the network. And then often the database server and the web server on different servers, and there's SQL that goes back and forth between them. Even if they're on the same server, it's kind of like a virtual network connection. There's the SQL software, there's the Apache web server. So you will click on a request. That request will be sent to a server using HTTP. Then maybe that will have some PHP that comes in. It goes and runs the PHP. It makes a connection to the database. The database reads some data, comes back, sends some stuff back, does a response. The response populates the object model, maybe runs some JavaScript, which also messes with the document object model, and then you see the document object model. You don't have to know this right now. I will hit this almost every single lecture, because in a web application, the notion that there's a browser, there's a web server, there's a database server, and there are different things going back and forth, and that web developer console is really looking at this area right here. And so you have to debug so many things, and there's a way to debug these things and debug these things. There's just so much more. And it's so cool. It's so cool. When you really understand how this works, then you can use any web framework, any browser framework, and this notion of database backend, web server middle, and browser. So again, this is not the only way to write applications, but the concept of the web browser and even mobile applications have kind of like these three layers sometimes, where they have code that runs in the mobile device, server code, and then database code. And so there's a lot to understand, and we'll just start picking this up one thing at a time, build a whole bunch of building blocks, and then put them all together so you really understand how web applications work.